Hello all. First of all, thank you all for joining the Blockchain Developers Meetup, and thank you for attending our first cast. We've created this meetup group so we can share what we've learned so far about the blockchain technology and create a community where everyone interested in the blockchain is free to share and receive knowledge. Some organizational stuff I'd like to share. We'll give our best for trying to host such online meetups, webinars, at least once a month. And we'll be hosting on-site meetups as well, because face-to-face communication and networking is what powers such communities. Third, and last but not least, everyone is more than welcome to give a presentation on a related topic. So if you have something cool to share, just drop us a line. There will be contact somewhere in the presentation. Okay. Some words about me. I'm Milen Radkov, the founder and CEO of Hack.bg, where we provide blockchain, web, and mobile development services and consultancy. I've been into web development for a long time, and since few years I'm very passionate about blockchain. Today's topic will be dark DAOs, and it's very interesting, so we've did some research and I'd like to share it with you today. So what is a DAO? A DAO stands for Decentralized Autonomous Organization, and the whole idea behind it is that a decentralized organization takes the concept of traditional organizations and decentralizes it. So instead of a top-down structure managed by a set of humans interacting in person and controlling property via the legal system, a decentralized organization involves a set of people interacting with each other according to a protocol specified in a smart contract on the blockchain. Theoretically, a DAO company could run completely autonomously if the platform provided sufficient rules and flexibility. But don't be mistaken in thinking that decentralized organizations has no governance though. The business structure relies on formal democratic voting process for taking decisions. Using DAOs, humans can coordinate and work towards a common goal at the global scale without relying on trust on third parties, and this has been enabled by the invention of the blockchain. This is an image showing the traditional top-down organizations and decentralized autonomous organizations. As you can see, the traditional top-down organizations have one legal entity and employment contracts, as well as many layers of management for coordination and enforcement of processes. As well as there are many information, decision and bottlenecks, as well as sources of corruption. In the decentralized autonomous organization, there is a distributed network of autonomous stakeholders. So there's no centralized legal entity and no employment contracts. Machine consensus around the token governs rule sets and smart contracts instead of legal employment contracts. So that's the main difference. How a DAO work? As we said, decentralized autonomous organizations run through rules encoded in smart contracts. They are entities that live on the blockchain and exist autonomously, but also they are relying on hiring individuals to perform certain tasks. A typical DAO is consisted of several things. In order to exist, a DAO needs some kind of internal property that is valuable in some way, and it has the ability to be used as a reward for certain activities. The funding takes place directly upon the creation of the organization, and as we said, DAOs don't have the typical top-down structure, neither executives or management. Once deployed, the entity is independent of its creators and cannot be influenced by outside forces. That means that DAOs are usually open source, thus transparent and incorruptible. A DAO's financial transaction record and program rules are maintained on the blockchain, and this approach eliminates the need to involve a trusted third party in a financial transaction. In order to withdraw or move funds from a DAO, a majority of its stakeholders must agree on the decision. This percentage could be specified in the code of the DAO. Even if bugs are found in the code, they could not be corrected until a voting procedure has taken place and the majority of voters agreed on it, which could leave non-security holes open to exploitation. A DAO cannot build a product or write code or develop a software, so it needs a contractor to accomplish its goals, and a contractor gets appointed via voting of a token holders. Proposals are the primary way for making decisions in a DAO. To avoid people overloading the network with proposals, a DAO could require a deposit to prevent people from spamming the network. After submitting the proposal, voting takes place, and DAO allows people to exchange economic value with anyone in the world, like investing, money raising, lending, borrowing, without the need of an intermediary, just by trusting the code. So keep that in mind. What's the current voting situation? In political systems, vote buying is considered election fraud around the world. In some countries, votes are being priced as low as a movie ticket. But there's good observation that the normal market mechanisms usually break for some reason, like the following. Vote buying is considered a crime, as we said. Where secret ballots are used, compliance is hard to enforce. A voter could get your bribe and vote however he likes. And even if a voter does sell their vote up front, there's no guarantee that he will be paid after. So here comes the blockchain. There are no such obstacles in blockchain voting systems. Vote buying could be conducted and run efficiently using smart contracts, and there are many end-to-end verifiable voting systems that allow voting using different devices and using blockchain only to store result of the election. Also, there are systems that conduct the voting process on-chain. So what are the challenges? On-chain voting schemes face many challenges, including privacy, latency, and scaling, and more. But all these are technical problems and will eventually be resolved. But what about vote buying? Vote buying is a different story. In general, electronic voting schemes are in some ways harder to secure against fraud than in-person voting, and have been the subject of general and academic interest for many years. So researchers took issue with electronic voting systems, noting that they offered voters a receipt that provided cryptographic proof of which way a given vote have been cast. This would allow for extremely efficient vote buying and coercion. The vote buying is harder to secure. The blockchain voting today is opting to implement the most naive possible form of voting, directly counting votes stored in plain text on chain. Unfortunately, is it not clear that better solution is achievable on chain? The current permissionless model is fundamentally hostile to voting, and there are some attempts to incorporate identity or second layer solutions, but in the end all permissionless voting systems that allow users to generate their own key in an untrusted environment are vulnerable, leaving spaces for many vote buying attacks. So for example, let's say we have a voting scheme where holders of a token get one vote per token they hold. They could change their vote as many times they want until the network reaches a certain block number, which will close the voting. The simplest attack involves vote buying smart contracts. Such contracts would simply pay users for their provable vote. Example implementation would be a simple contract that is holding your ERC20 token until the end date and then return it. In this example, the trust is already inherent in the blockchain, which is an advantage. But there are disadvantages as well, such as it will be possible to publicly tell how many votes are purchased after the vote is over. So, because this is required because the flow of the payments in today's smart contract systems require it. A simple solution could be solved by private smart contracts for the vote buying initiative. The second and most concernable possible vote buying attack is by involving the use of trusted hardware like Intel SGX, for example. The trusted computing is incorporating 6 key technology concepts, which are all required for fully trusted system: endorsement key, secure input and output, memory protection execution, sealed storage, remote attestation, and trusted third party. Trusted hardware are providing a way to prove that you are running a certain code or software. For example, if Alice wants to prove to Bob that she is running a certain computer program, this could be achieved by the remote attestation feature of Intel's SGX, Trusted Computing. Trusted hardware is usually being used as a way to prove you're not running a malicious code or to verify you're running a valid licensed software. In our case, the software being run and proved by the trusted hardware will be a cryptocurrency wallet with the restriction to vote only in certain way. The SGX would guarantee the user that the wallet could not steal or spend his money, and they can use the wallet as any other normal Ethereum wallet. With the help of the trusted computing, it's possible to trigger automated votes based on the predefined conditions. Users could claim their payment after the period of time after the vote ends. So remember what a DAO was, right? What's a dark DAO? A dark DAO is a trustless, decentralized autonomous organization with the goals of manipulating votes, elections, and whatever other you can think of, pump and dump schemes, and much more. In a dark DAO, the network would be supported by the vote buyers, running SGX enclaves that execute a consensus protocol, let's say, and the whole thing would be invisible from the outside. The vote buyers can keep track of the total funds that were used in the system and hide this from the outside with the help of the privacy features of the SGX. The users would receive payments for their participation, and the vote buyers would be guaranteed that they pay for their desired votes. What makes the organization dark is that the vote buyers could opt not to reveal how many are the participants in the system, and an attack could happen anytime with no trace if it fails. Because that kind of organization exists off-chain, there's no system that could detect, censor, or stop the attack. For now, there are some drawbacks for such dark DAOs. The main one is that SGX requires a license to be granted by Intel for running a software, but in the nearest future there will be sustainable increase of the trusted hardware providers that offer remote attestation feature, and more likely the SGX would not be required for this kind of attacks. So dark DAOs have implications far beyond what we've talked. So every voting or financially incentivized schemes should be very careful while developing their permissionless model. Be careful when you're developing and think twice. Thank you. If you have any questions, I'm here to answer them. So let's see. Okay, we have a question. Maybe we can put as a condition for using the client software for voting the user to allow full monitoring of the system. Yeah, you're right. The condition is put by the developer with who is developing the trusted software that is being executed on the client's computer. So the condition could be anything. As I mentioned, it could be that the license key is verified, that for example with the wallet he can vote only yes, that he's running a certain piece of code, and every other possibility that you imagine. Is that answering your question? Yeah, okay. Thank you as well. Any other questions? Okay, we don't have any questions for now, so I'm leaving you a slide of resources where you can dive deep into the topic. And thank you again. I'll be sharing the video and links for the resources shortly. Thank you.